This is our last video on this little section, question 8. So this is still Newton's first and second laws of motion, so forces in motion. The example is question 8. Resultant force of 3I plus 8J newtons. So this time we've got our resultant force in vector form. So we're going to use F equals ma in this particular form, and this acts on a particle of mass 0.5 kilograms. Part A, find the acceleration of the particle in the form pi plus qj. So our force is mass times acceleration. So if this is our resultant force, 3I plus 8j, that will be the mass, which is 0.5, times by the acceleration. The acceleration is in the form pi plus qj. Okay, this is all in kind of vector form now rather than just values. We've got vectors, so they've got two different components, the I and j components. So if we divide both sides by half, or if you think of it like this, you can times up by 2. 0.5 is a half. So we times up by 2 to get rid of this half here. Then we'll get 6i plus 16j equals pi plus qj, and equate our parts. So p must be 6 and q must be 16. So therefore the acceleration of the particle is 6i plus 16j meters per second squared. Okay, so we're just looking at it in a slightly different form with these vectors rather than just values. It's the same kind of idea. In part B, find the magnitude and bearing and acceleration of the particle. So the acceleration, so this particle is starting here, it's going 6i, so that's 6 to the right. Use the rule just to neaten it up. So it's going to go 6 units to the right, 6i, 16 up, this isn't to scale. So it's going in this particular direction, so we've got 6i here, 16j here, so the resultant force is on this diagonal. It's not 45 degrees, it's not to scale. So we're going this way, this is the way that we're accelerating. And so we can work out the bearing that it's going off in, and we can work out its magnitude. So the magnitude is just Pythagoras. Gets the absolute value. So the magnitude of the right angle triangle here, we know that the hypotenuse is the square root of 6 squared plus 16 squared. So we've got 36. And 256, isn't it? So you get root 292, which is 17.1. So that's the actual value of the magnitude of the acceleration, 17.1 meters per second squared. And then we can find the bearing as well. Oops. So the bearing is an angle, so if we find the little angle here, alpha, then we know if we draw our north line from where the particle starts, the actual bearing there will be that value theta there. So we can do 90 minus alpha. So tan alpha is opposite over adjacent, so 16 over 6. Inverse tan both sides, you get 69.4. And therefore the bearing of acceleration is going to be 90 minus this. So we get 020. I remember we need a 0 at the start for a bearing. 0.6 degrees to 1 decimal place. And that's the bearing. So here's our magnitude of the acceleration, and that's the bearing of our acceleration that it's going off in. Okay, 9 and 10 should be quite quick. So still in this kind of vector form, these i's and j's, so we've got a direction as well as all our kind of magnitude. This is question 9. So 9 says, 3 forces are acting on a particle of mass 3 kilograms, find the acceleration. So if all 3 forces are acting, then the resultant force, so we've got that's force 1, F1. We've got F2, which is minus 5i plus 4j. We've got F3, which is 6i minus 5j. And they're all acting on a particular particle. So if they're all acting on the resultant force, will be all these added together. Collect all your i's, collect all your j's. So 2 minus 5 is minus 3. Minus 3 plus 6 is 3i. We've got 4 plus 4 is 8, minus 5 is 3j. So that's our resultant force, and we know that our resultant force is mass times acceleration. So our resultant force is the mass of the particle, which we're told is 3 kilograms, times by its acceleration. So to work out A, we divide by 3. So therefore the acceleration of the particle is I plus j meters per second. Again, in this whole vector form is how we're looking at these kind of questions. And then finally, number 10. So a boat is modelled as a particle of mass 60 kilograms, being acted on by 3 forces. So similar again, this time we're told that it's accelerating at a particular rate. Find the values of P and Q. So again, we've got 3 forces. This time they're in column vector form themselves. So there's the first one, there's the second one, we don't know. Here we've got P and Q. And then we've got F3, which is minus 75, 100 newtons, and they're all acting on a particular particle, particular boat. So our resultant force from these 3 forces is just the sum of them. So it's F1 plus F2 plus F3. So this plus this plus this. So we can add all the x values together, the top values. So 80 minus 75 is 5, so 10p plus 5. We can add all the y values together. 50 plus 100 is 150, so it'll be 20q plus 150 newtons. That's our resultant force. And again, we know that our resultant force is the mass multiplied by the acceleration. And this time we're told the acceleration, should I put this at the start? Sorry, the acceleration is 0.8 minus 1.5 meters per second squared. So our resultant force, 10p plus 5, 20q plus 150 is the mass, which is 60, times by the acceleration. And when we multiply a vector by a scalar, so 60 by this, when we times them, because they're next to each other, we just multiply both bits. So we get 10p plus 5, 20q plus 150 staying the same. And we get 60 times 0.8, which is 48, and 60 times minus 1.5, which is minus 90. And then we've got equivalent vectors. So the x bits will be equal, and the y bits will be equal as well. So we can form 2 different equations. So the x bits must be the same. Minus 5 divided by 10, so p must be 4.3. And the y bits must be the same, so 20q plus 150 is minus 90. Minus 150 from both sides, divide by 20, and we get minus 12. And so we found P and Q. Same idea, this whole idea of this resultant force being mass times acceleration is the same in each case. Here we are, mass times acceleration. So we're just getting used to the slightly different forms they can ask for. If they put it in this vector form, I plus j, we can work out its magnitude, its bearing, or we can just leave it in its kind of form and get into grips with what they mean and how we can interchange them into these different types. That's it for this video. Next one, I'll look at Newton's third law, connected particles and pulleys. So there'll be note sheet with that, examples with videos, and some exercises for you to have a go at.